Hello everyone, and welcome to derivatives of inverse trigonometric functions. So remember that obviously a trig function is something like sine of x. So an inverse trig function is when you know the ratio and you're trying to figure out the angle. So normally when you see y is equal to sine of x, you would give somebody the angle, like what is sine of pi halves? And sine of pi halves is 1. So the x is the angle, which we often refer to as theta, and the y is the ratio of the sides in a triangle. So at a certain theta, then you could figure out the ratio. Inverse trig, if somebody says y is equal to inverse sine of x, that means now I'm going to give you the ratio and you're going to give me the angle. So if I say y is equal to inverse sine square root of 2 over 2, remember inverses switch x's and y's. So now I'm giving you square root of 2 over 2, and you say, oh, that happens when you're at pi fourths. Okay? So the good news is that it's just a formula. You just have to memorize it if you're in AP, and you just have to put it in your appendix if you're in honors. The bad news is there is a lot of algebra in this section. So we're going to go ahead and do that now. So before I do number 1, I see that I'm going to be doing inverse sine. So I'm just going to write that formula off to the side because I can't see both pages at once, obviously. You can. 1 over the square root of 1 minus u squared. But I'll be able to explain it better with the formula right there. Okay, so literally if you're taking the derivative of an inverse sine function, then the answer, y prime, is going to be 1 over the square root of 1 minus whatever this is. So in this case, this is x squared. So this is our u. But I actually want u squared. So I want x squared squared. And then lastly, times the derivative of u, which we keep calling the derivative of the inside. So times 2x. That gives me multiplying a whole number by a fraction, change it to a fraction so you can go straight across the top and straight across the bottom, 1 minus x to the fourth. Remember, even though 1 is a perfect square and x to the fourth is a perfect square, the subtraction stops you from actually taking the square root. Okay, let's see, it was just a formula. Very easy. Next one. For cosine, this is an interesting formula in that it's exactly like the sine formula, but it's going to have a negative on top. So y prime is 1 over the square root of 1 minus, this time this is our u, is always going to be u squared here, times the derivative of u. So just make a little equation over here. I would make this x to the negative 1. The derivative of, I called it w, I guess I should have called it u. Just was trying to give it a different name. So u is equal to, du is equal to negative x to the negative 2. Negative x to the negative 2. So if you have to, do it off to the side. If you can do it in your head, that's great. So what does this become? So I'm going to leave the negative on top with the 1, but the x to the negative 2 can move to the bottom. And then I have a square root, 1 minus 1 over x squared. Now here comes your first really tricky algebra. You cannot leave it like this. You can't have a complex fraction, which means a fraction within a fraction. So first, I'm going to give this a common denominator. I'm going to make this 1 x squared over x squared. That way I have x squared times the square root of x squared minus 1 over x squared. So I gave that a common denominator. Now I can take the square root of the bottom. So the top because of that subtraction, has to stay there, but the square root of x squared is x. And then this x squared and this x cancel, leaving me x square roots of x squared minus 1. It is all about the algebra. Next one. I love cotangent. It does have a slightly easier formula. It is -1 over 1 plus u squared. So what is u in this case? Square root of x, or when I go to do the derivative, I'm going to change it to x to the 1/2. But I'm going to leave it as a square root right now. So it's -1, negative because it's the cotangent. Tangent is positive. 1 plus u squared times, notice all three of these are times the derivative of the u. You can't forget that. I always recommend that you do it off to the side. Du is 1/2 x to the negative 1/2. So 1/2 x to the negative 1/2. Can people get this far? Absolutely. What's tricky? The algebra. So when you're multiplying a fraction by a fraction, -1 over 1 plus, now a square root of x squared is just x. So on this fraction, that 2 is on the bottom, and that x to the negative 1/2 can be x to the positive 1/2, or square root of x, on the bottom. So I have some really good news for you, and that is in calculus, we do not require you to rationalize the denominator. You can leave that square root of x right in there. I will say what you are required to have, though, is parentheses around the 1 plus x. If you forget the parentheses around the 1 plus x, the 2 square roots of x would only be being multiplied by the 1 or the x. So make sure you have that. But you don't have to rationalize the denominator, which is really nice. All right, number 4. Y prime is equal to, so here's the formula again, 1 over the square root of 1 minus, this is going to be our u, you might always want to write it off to the side, u squared times the derivative of u. The derivative of u is -1. That was a nice one. What does that give me? -1 over, make sure you simplify. This is not considered an acceptable answer because it does become much more simple. So this little section is 1 minus, and then this is, when you expand it, 1 minus 2x plus x squared, 1 minus 1 plus 2x minus x squared. So notice that that all cancels, and you just get 2x minus x squared. Another tangent one coming up. I love the tangent. It does have the easiest formula. So the derivative for tangent is, well, let me just rewrite that 1/3, is going to be 1 over 1 plus u squared. So off to the side here, what is my u? Always good to identify u. X over 3. So 1 plus u squared times the derivative of u. So that's another reason why I put it off to the side. So some people really struggle with x over 3. If it helps you, you can write it as 1/3 x. People are usually more successful at taking the derivative, which is just 1/3. So du is 1/3. Got my little prime symbol there. So y prime is, I'm going to put the two 1/3s together to make 1/9. And I'm going to simplify this a little bit. This becomes x squared over 9. Numerator times numerator is 1. Distribute the 9, and it's 9 plus x squared. Not too bad, right? Just wait, they get harder. Sorry. All right. Number 6, another cosine one. Actually, I'm just going to take a minute and I'm going to write down a bunch of answers so that if there is anybody that would like to do these on their own, I will say they get significantly harder, but it just occurred to me that some of you might like to try it on your own. If I go too fast for you, you can just screenshot. Number 9, 4 over x squared plus 4. Number 10, 4 over x square roots 25x to the 8th minus 1. Inverse sine of x. Number 12, inverse cosine of 2x. 1 over 136. Y is equal to negative 1/2 x plus 1 minus 3/4. All right, and then that's theory after that. So if you want to try any of those examples, there's the answers for you. But I will do them with you. Okay? All right, starting with number 6 here. So again, the key is to know the formula. For cosine and sine are the same with the exception of a negative. So I like to put my u over here and my du, kind of get that out of the way. And now the derivative for cosine is negative 1 over the square root of 1 minus u squared. So that you square the whole thing, put the parentheses first, and then put your u in, times the derivative of u. So times the derivative of the inside, which is 2. This gives me negative 2 over the square root of 1 minus 4x squared. Again, you do not have to rationalize the denominator in calculus. It's a little benefit. All right, our first cosecant one. I'm always going to write my u first, especially when it's this complicated. I'm going to change it to x plus 1 to the 1/2. And my du is going to be 1/2 x plus 1 to the negative 1/2 times the derivative of the inside, which is 1. Doing your u and your du first will really help you. The derivative of inverse cosecant is negative 1 over x, or u, which is the square root of x plus 1, times, it's technically in absolute value, but a square root is always going to be positive, but I'll write it just for this one, times the square root of u squared, so square root of x plus 1 squared minus 1, times the derivative of u, which we already figured out, is 1/2 x plus 1 to the negative 1/2. A lot of simplification required here. First, you don't need the absolute value because a square root's already going to be positive. Second, the square root squared is just going to be x plus 1, and then there's still a minus 1 there. And then the derivative of u, both of those are actually in the denominator. The 2's in the denominator, and the negative 1/2 I move to the denominator. And I'm going to change it back to a radical. This radical and this radical, when you multiply them together, give you x plus 1. So I have my 2. I have just x plus 1 now. And then these two ones cancel, and so I have the square root of x. This is my negative. This is a perfectly acceptable answer, or negative 1 over 2x plus 2 square roots of x. But you will lose points if you lose your parentheses. It's not 2x plus 2 square roots of x. It's 2x plus 2 times the square root of x. So you do need to watch out for that. I don't mind you distributing, just don't lose your parentheses. Number 8, starting to get a little trickier now. We've got two things going on. The first is a product rule and an inverse trig function. That's a lot. So the first thing that I'm going to do is I'm going to change this to 1 minus x squared to the 1/2. And then I'm going to remember that it is product rule. So y prime is the second times the derivative of the first plus the first times the derivative of the second. This is a hard derivative. 1/2. 1 minus x squared to the negative 1/2 times the derivative of the inside. Don't forget that. And now I'm going to do the derivative of the inverse cosine function, which is -1 over the square root of 1 minus u. So this is the first time where our u has just been x. That's because there's enough other stuff going on. U squared times the derivative of u, but since u is just x, the derivative is just 1. All right, you did the calculus. The rest of it's algebra. So this is the square root of 1 minus x squared. This, the 2's cancel. The x times the x makes negative x squared. And that radical, I'm going to move to the bottom. 1 minus x squared, because it's a negative 1/2. If you want, you can write this as negative plus if you want to help see the terms. And then plus 1, so the negative and the negative made a positive, square roots of 1 minus x squared. So they do have the same denominator, so I can put them together. And I'm going to put all three of them together by multiplying this one on the top and the bottom by 1 minus the square root of 1 minus x squared. Square root of 1 minus x squared. Now I'm going to have a common denominator for all three of them. This numerator, the square root and the square root cancel. 1 minus x squared minus x squared plus 1, all over the common denominator of 1 minus x squared. And that gives me 2 minus 2x squared over the square root of 1 minus x squared. These are hard. I know it. So good job. All right. So we have two different inverse trig functions happening at the same time. So on the first one, our u is 2 over x, which is the same as 2x to the negative 1. And so my du would be negative 2x to the negative 2. In this one, my u is x over 2, and so my du is just 1/2. So that where that x is and where that 2 is definitely makes a difference. All right, derivative. Cotangent and tangent inverses have the same exact derivative, except the cotangent is negative. -1 over 1 plus u squared times du. Isn't it nice to have done that ahead? Really highly recommend that. And now the derivative of inverse tangent is +1 over 1 plus u squared times the derivative of u. So there's the calculus. The rest of it is algebra, and it's not easy algebra. So This negative 2 is technically on top, so I'm going to put it with the negative 1. This x squared can be moved to the bottom. So this bottom is 1 plus 4 over x squared, and now I'm bringing in the other x squared. We'll simplify it more in a minute. So this is 1, and again, this is 1 plus x squared over 4, and it's getting multiplied by 2 on the bottom. And the 1 times the 1 just made 1, which gave me 2 over, when I distribute that x squared, I get x squared there. And when I distribute the x squared to the 4 over x squared, I just get 4. And then when I distribute the 2, I get 2. And when I distribute the 2 here, I get x squared over 2. So I'm not allowed to leave a complex fraction. So I'm going to multiply the top by 2 and the bottom by 2. And that gives me, this one doesn't change, this is still x squared plus 4. And this gives me 2 in the numerator. And when I distribute that 2, I get 4. And when I distribute this 2, they cancel, which was the whole reason I did it. And then, of course, now they have the same denominator, which was just fortunate. And I get 4 over x squared plus 4. So the calculus was literally just plugging in a formula. The rest of it was some really tough algebra. All right, we've got 3 more of these. Number 10. Again, I think it's really helpful to identify u before you start. 5x to the 4th. And then du is 20x to the 3rd. The derivative for secant, inverse secant, is, can you hear me looking? I always have to look. I don't have them memorized. Sorry, I don't have to take the AP Calculus exam, so I don't have to memorize them. Isn't that awful? All right, is 5x to the 4th. And you might be thinking, oh, x to the 4th and it's positive 5. I don't need the absolute value, but keep it there for now and you'll see why. And then times the square root of u squared. So 5x to the 4th squared minus 1 times the derivative of u, which is 20x cubed. So that gives me 20x cubed over 5x to the 4th square roots of 25x to the 8th minus 1. So now when you simplify this, the 20 and the 5 can make 4. And you can knock off 3 of those x cubes with 3 of these. But when you do that, this is why I left the absolute value there, which ironically I don't have my answer, but it should be there. You have to have the absolute value now because now that it's not to the 4th power, it's not necessarily positive. So we do want it to be positive. So it's going to be absolute value of x, 25 x to the 8th minus 1. Great. Number 11. I don't know if you see this. Product rule. And I would switch this one to 1 minus x squared to the 1/2. Those are 2 changes that I would make. I would identify anything that's being multiplied so you don't forget to do product rule, and then I would change square roots to exponents. All right, y prime is the second times the derivative of the first plus the first times the derivative of the second. The derivative of inverse sine is 1 over the square root of 1 minus, it's u, but in this case, u is x, 1 minus x squared times du, which in this case, it's not negative 2x. The u was just x, so the du is just 1. Easy place to go wrong. So I did my product rule, but there's still a whole other half of the problem here. Plus 1/2 1 minus x squared to the negative 1/2 times the derivative of the inside. It is so much to remember. You can do it. So this gives me inverse sine of x plus x over the square root of 1 minus x squared plus my 2's cancel, but don't lose that negative, negative x, and this is a square root, but it's on the bottom because it's negative. And then look at that. Those cancel. And so my answer is just inverse sine of x. On this next one, we have another product rule. Be really careful of those. Two different functions being multiplied. And I have another radical. So I'm going to change that to a 1/2. On my inverse trig function, my u is 2x. And my du dx is equal to 2. Always good to have that done in advance. All right, derivative, product rule. The second times the derivative of the first plus the first times the derivative of the second, which for cosine is negative. And then it's the square root of 1 minus u squared. U is 2x. And then times du dx, which is 2. We're already pretty far out in the problem, but don't forget there's still another part. This is the 1/2 that's just already there. And this is the 1/2 from bringing down the 1/2 before I lower the exponent to negative 1/2. And yet another derivative of the inside, super easy to forget. All right, let's simplify that. Inverse cosine of 2x plus, so when you have whole things being multiplied by fractions, sometimes it's really nice to just put them all over 1, and then you can see clearly that it's a numerator. Sorry, I'm thinking for a second. That it's going to be a numerator times a numerator, and then a denominator times a denominator. And then on this one, the minus and the minus become a plus. The 2 times 2 is 4. They cancel with the 8 to give me a 2x all over 1 minus 4x squared. So these end up being the same, and that's my answer. So that was a lot of practice problems on inverse trig functions, just trying to get them down. We're going to move on to word problems now, but make sure you do some homework on that and make sure you can do them yourself. Okay, a particle moves along the x-axis so that its position at any time t is x of t is equal to inverse tangent square root of t. What is the velocity? As soon as I see position and velocity, it's sometimes really nice over to the side to write SVA. Remember that this is usually an S function, or it could be x. So in this case, it's x, inverse tangent square root of t. And remember that velocity is going to be the derivative then of x with respect to t. But since this is in respect to t, I can go ahead and do that. So the derivative of tangent, so velocity is dx dt, which is going to be 1 over, actually I'm going to stop and do my u. You know, I'm a big believer in that. U is t to the 1/2. Du is equal to 1/2 t to the negative 1/2. Helps to have that in advance. So tangent is 1 over 1 plus u squared times the derivative of u. So here's my u squared, and then the derivative of u. So velocity is, so this becomes 1 plus t, and this, the 2 is on the bottom, and that square root of t is on the bottom. And before you try and simplify it further, you're not really required to simplify it further because they want to know the velocity of the particle when t is 16. You can plug in a 16 now. So v of 16 is 1 over 17 times, I'm just going to erase this a, it's in my way, 1 over 2 square roots of 16, which of course is 4. 4 times 2 times the square root of 17, 1 over 136. Oh, that really doesn't want to write that. 1 over 136. You could have plugged in the 16 even earlier, but I did simplify it just a little bit. Next one. Find the equation of the line. As soon as I see that, I go straight to my answer. It's going to be y is equal to some kind of slope times x plus 1 plus y. So remember, to get the y, you need the y equation. To get the slope, use y prime equation. That's going to be the key. So let's do y first. Y is equal to inverse cotangent of -1. So this is actually a little bit tricky because you've got to figure out when cotangent is -1. So this is a lot of pre-calculus. So cotangent is negative in quadrants 2 and 4. So it's either the 2 or 4 answer, and it happens at pi-fourths. So 3 pi-fourths or negative pi-fourths. What you have to do, though, is remember which two answers which two quadrants the answers for cotangent is in. And unfortunately, I don't think that we spent a lot of time on that. You might remember that inverse tangent was always quadrant 4, and inverse sine was quadrant 4, and inverse cosine was quadrant 2, but we didn't spend very much time on cotangent, secant, or cosecant. So way back at the beginning, there is a formula just for that because they don't expect you to remember. So if you have to do inverse cotangent of -1, they're like, yeah, no one's going to remember that. So instead, you can do inverse tangent of -1 and then just subtract from pi-halves. So inverse tangent is negative pi-fourths. So negative pi-fourths. That's what that formula was for that I gave you right in the beginning, that I just kind of skipped over. So 3 pi-fourths. Okay? So 3 pi-fourths. There we go. So 3 pi-fourths. The easier part is going to be doing the slope. So y prime is -1 over 1 plus u. U is just x in this case. 1 plus x squared times the derivative of u, which is just x, so it's just 1. So y prime is equal to -1 over 1 plus -1 squared, which is -1/2. So I put that right in here, and I have an equation. Okay? So again, the trickiest part of this problem was not writing the equation of a tangent line. You've done that a million times. It was literally this little piece right there. If you're in honors, I'm not going to give you anything that hard. If you're in AP, then you need to know how to get the inverse cotangents, which was something we did not tackle in pre-calculus.